Welcome to After Dark Online. Thanks for joining us again as we continue to explore our world through science, art, and conversation. My name is Sam Sharkland, and I'm a program developer as part of the team that produces After Dark. This program is virtual, but the Exploratorium is located on Pier 15 in San Francisco, on unceded territory traditionally belonging to the Ramaytush Ohlone people. We recognize that we are guests on this land, and we honor the conservation and stewardship that the Ohlone have offered for the ecology we inhabit, both past, present, and continuing into the future. This month at After Dark, we're noticing the changing of the seasons. Leaves are falling off trees, some of the world is going into hibernation, and we're also noticing that there are extreme weather events that are threatening our shared ecologies on both coasts of our country. So, this month we're looking at themes of decay, destruction, entropy, what happens when things fall apart, and what room is made for new arrangements and revisions when that does happen. Kicking it off, tonight we're looking at wildfires. Wildfires are a common occurrence in the western United States, but recently, as many of us have been painfully aware, wildfires have offered destruction in magnitudes unseen in the past. So what can we learn about this process? Later on, we'll hear about prescribed fires and community-rooted fire management from Lenya Quinn Davidson, director of the Northern Californian Prescribed Fire Council and core staff member with Fire Adapted Communities Learning Network. But first, the science behind wildfires with Dr. Yannette Cobian-Iniguez. Yannette is an assistant professor at the University of California, Merced, Department of Mechanical Engineering. Prior to her current position, she was a postdoctoral scholar at the University of California, Berkeley, working on smoldering fire behavior of simulated wildland fuels. She completed her PhD at the University of California, Riverside. Yannette's focused areas of fire behavior and heat transfer and fluid dynamics of environmental phenomena. Her new research group at UC Merced will focus on fundamental wildfire behavior, fire dynamics, and the effects of wildfire on air and water quality. In this talk, Yannette will share more about how wildfires behave, wildfires fuel, and how they are studied in lab settings and beyond. We hope you learned something from this presentation. Enjoy.
Thank you for that kind introduction. It's great to be here. My name is Yannette Cobian-Iniguez, and I am an assistant professor in the Department of Mechanical Engineering at UC Merced. And today I'll be talking about some fundamentals on the science behind wildfires. And it's my great pleasure to be here sharing this information with the audience, especially in these times. So I'm a mechanical engineering by training. And so this gives you a little bit of a perspective of the perspective I looked at fires from. And I study wildfire behavior and fire behavioral behavior in general. I wanted to give a little bit of background of how I've studied fires in the past, in part to also give an insight of how mechanical engineers might study wildfires, since I get this question a lot. A lot of folks don't know that mechanical engineers study wildfires at a research basis. So I study wildfires using an array of different methods. And one set of methods is laboratory scale studies. And for these types of laboratory scale studies, I've used large wind tunnels and small wind tunnels to study different types of fire behavior fundamentals. So trying to extract some basic science of fire spread and other fire behavior that is important for us to understand in order to derive some fundamental physics and mathematics that can feed into models that will help us understand how fires behave. So I've used large wind tunnels, such as the one that you see here in the left, and I've also used small wind tunnels in trying to understand basic fire behavior. But in addition to this fire behavior laboratory scale perspective, I've also used satellite data to study fires from a landscape scale perspective. And here's a picture of when I was a intern at the NASA Develop program at NASA Goddard, where I was studying the fire, some fire behavior patterns in the Kenai Peninsula of Alaska. And this particular project was very interesting because the bulk of my research is in California wildfire behavior, and here I got some insight into fire ecosystems in other parts of the world. So with that, I want to give a very brief background of what we're going to be talking about today and the perspective that I'll be taking for the talk. I'll preface by saying that the talk is designed with those in mind that don't have a lot of background in fire behavior or wildfire behavior, or are beginners in wildfire behavior knowledge. So you can think of it as a very fundamental talk. And I'll be focusing on explaining how the three primary drivers of fire behavior may affect fires, and in describing these drivers of fire behavior. So with that, we know that there's three main drivers of fire behavior. And these main drivers are topography, so the shape of the land, fuels, and weather. And within each of these three categories, we have an array of different subcategories of drivers. So throughout the talk, I'll be walking you through how parameters within each of these categories affect fire behavior. So let's start with fuels. And fuel, very roughly defined, is any material that can burn. And in wildfire specifically, and in fire, the burning of wildland fuels, we're specifically looking or considering wildland fuels. So plants, trees, grasses, those are some examples of fuels when we're talking about wildland fire behavior. So the type of plant or tree, or fuel as we call it, affects how a fire will burn. So a shrub or grass or a coniferous tree might burn very differently from each other and might create different fires in the landscape scale and also in the small scale when we're looking at in the lab. So here I'm focusing on the state of California, primarily because that's the main area of interest that I've studied thus far. And I wanted to present this map, which includes information of the types of fuels that we have in our state. So in California, we have various types of fuels, from agricultural fuels, like in the Central Valley. We have deserts, we have forests. In the south, we also have some chaparral shrub. And so the type of fuel that we have in each region will be driving a different type of fire behavior. And so those are some pictures to kind of visualize the type of fuels that we're talking about throughout this map. So now that you have a little bit of just insight into what is it that burns in a wildfire, and note that I'm mentioning only a wildfire. I'm not talking about wildland urban interface fires where we have structures or houses burning um, near a wildfire. Though that's it would include urban structures such as houses as fuels. Here I'm just focusing on wildland fuels. So now you have some insight on the types of wildland fuels that might drive a wildfire. And you might be thinking, well, what aspects of these fuels are driving the type of wildfire behavior that is in the wildfires? So first of all, we have to consider the amount of water in a plant or a tree. And that is, in the field, we call that fuel moisture content. And we know that plants and trees get water they need to survive from soil and air, right? And plants will store this water or moisture in the leaves, branches, trunks, and other elements of the plant. The amount of water in a plant, so the fuel moisture and the water in the plant, will affect the possibility of starting a fire, and we call that the ignition potential. And also, it will affect how a fire will spread. So we're talking about two different things. The potential for ignition, just starting a fire, that's affected by the amount of moisture in the plant. And then once we get an ignition, and if that ignition is successful, we may also get a fire that spreads. Not every ignition is successful, but if it is and it spreads, the amount of water in the plant will affect the rate of spread and the intensity of spread. So, for example, when we have plants with large amounts of water, you could say it's harder to catch on fire, so it's harder to ignite. When we have plants with low moisture content, so very small amount of water, it may very easily catch on fire, okay? And again, this is a simplistic explanation. There's a lot of nuance in actually understanding how fuel moisture may affect how a fire might start or spread, and it may also vary within species. But in general, we can kind of start painting a picture with this very general perspective on the effect of fuel moisture on fire behavior. So in addition to the amount of water in a fuel or the fuel moisture, the amount of trees and plants or fuels and the distance between them in the landscape may also affect how a fire spreads. So when we have lots of plants or trees, fuels, close together, like you see here in the picture on the left, it may be much easier to spread the fire. So for example, here we have these three trees that are catching on fire. And if we have what we call an ember, so a piece of one of those trees or a series of pieces from one of those trees that catches on fire, and we have nearby fuels, such as the shrubs that you have here, that fire might easily transfer to neighboring fuels. And so these dense fuels in close proximity to each other might facilitate the spread of fire. On the other hand, when we have sparse fuels far away from each other, that might mean that it's a bit harder to spread a fire, as when we have an ember. The ember might not make it to the neighboring shrub, or if we are considering fire spread through direct flame contact, the flame might also not reach the shrub. Again, this is in general terms, and I'm not including elements such as wind speed and topography, which, for example, wind speed, even if we only have one element that's on fire, if we have very high wind speed, there is a chance that the ember might be carried to the neighboring fuels. So it's important not to oversimplify the complex fire behavior, but I am speaking in very general terms. All right, so that gives you some of the main drivers fire behavior within the fuels category. There's other drivers, which includes elements of the fuel species, the fuel particle size, and the fuel bed. But I've given you just less than a handful of them to give you a general overview. So with that, let's transition to weather parameters that might affect how a fire behaves. And when we're speaking about weather, we're specifically talking about parameters such as air temperature, relative humidity, and wind conditions, right? So wind direction and magnitude. So specifically speaking about temperature or air temperature, ambient air temperature affects whether a fire can start or spread. So when we have high temperatures, we might get something we call fuel preheating. So the fuel might not be burning, but it's getting radiation from the sun and it's preheating, and it's much easier for a spark to ignite. In addition, once we have a fire that has started, if we have fuels that have preheated, in this way, it's easier for neighboring fuel particles to ignite and thus facilitating the spread of fire. Furthermore, as I very briefly mentioned in some of the previous slides on fuels, the wind can also dramatically affect how a fire spreads. And this is a very basic, definition of wind. Wind in general is air in motion. And we know that wind can have a direction and a magnitude, right? And this, both the direction and the magnitude usually affect fire behavior. Strong winds can increase the chance of a fire starting, such as when we have these embers that we were talking about in the fuel part of the talk, but also in the rate of spreading. So not only igniting and transporting fuel elements from one fuel to another, but also spreading the fire through direct flame contact, preheating. The wind may transport the heat from a fire through convection, as we call it in mechanical engineering, through the fuel and preheat the fuel. So wind is working at many different angles and at various scales to affect how a fire will spread. In addition to temperature and wind, another aspect of weather that affects how a fire will behave is the amount of moisture in the air, and that's what we call relative humidity. And relative humidity, the amount, roughly speaking, is the amount of moisture in the air. And as I mentioned before, plants and trees and different fuels will absorb this water from the air to survive and will store it within their elements. And so this also will affect the fuel moisture in our fuels, so hence will also be affecting the fire behavior. Around the earth, we have different patterns of relative humidity in our country and in our state, right? So the fire behavior when we're focusing on relative humidity will vary depending on where we are. So in places that have high relative humidity, such as tropical places, this will determine the amount of moisture in plants. So this will also delimit the fire behavior, right? And then places with very low relative humidity, such as deserts and Mediterranean areas, such as Southern California, these are places with less, which are likely to have less moisture in the air, less patterns of low relative humidity, and this will also affect how a fire will behave. All right, so that kind of concludes the basic explanation of some of the major weather parameters affecting fire behavior. And so far we've talked about how fuels may affect fire behavior and how weathers may affect fire behavior. And if you remember from that nice Venn diagram or triangle that we have from the start, we're missing one element, which is topography. So I'll very briefly go over one of the ways in which topography or the shape of the land may affect how a fire behaves. And there's various types of topography around the world and in our country and in our state. And we have everything from, even in California, we have everything from mountains, hills, valleys. And so we will deal with different types of fire behavior patterns at the small scale and also the landscape scale, depending on where the fire is developing. And one of the ways in which fire might spread differently due to topography is, in some instances, fires might burn faster when they're going uphill, as when the tilting of a flame is facilitating radiative heat transfer and hence kind of pushing the fire to go faster uphill. So that's just one way in which topography might affect fire behavior. But that kind of concludes my discussion on how fires might spread differently depending on and ignite differently depending on the type of fuels, weather, and topography that we have. In addition to this discussion, I also wanted to give just a brief introductory talk on how we may study wildfires from space. So we might integrate some of these parameters or other landscape parameters in order to really observe fires from spread and observe the behavior of some fire drivers from space. So for that, I have just a quick definition of what a satellite is. So a satellite in general is any object that goes around a planet, right? And there's two types of satellites. There's natural satellites and artificial satellites. And here I'll give you all a couple seconds to guess the name of one natural satellite. All right, with that, gives the answer. And the moon. The moon is probably the most widely known natural satellite, right? It's orbiting our Earth. In addition to natural satellites, we have artificial satellites or human-made satellites, such as the one in the picture here, right? And these are artificially made satellites that will be circling the Earth or a planet. Here I have a very quick animation. So how do satellites work? So satellites are placed into orbit and they go around the Earth collecting data about the Earth, right? They're collecting either visual data or different types of sensing data that provides us information on how different phenomena occur on Earth. And you might ask, well, how do these satellites get launched into orbit? For that, I have a quick video, and this is a video from the NASA Goddard Space Flight Center. They have very neat information on the NASA website on satellites. So here we have the launching of the Landsat satellite. So usually they have satellites that launch from somewhere on Earth, and they are propelled by a rocket. And so we here see the satellite going through the atmosphere, getting launched into space, and then the rocket eventually separates from the capsule where we have the satellite contained. The satellite will be released, and it will, if it has solar panels, the panels will open, and then the satellite is launched into orbit or placed in orbit, and it will be going around the Earth collecting various types of data, right? And sorry about that. Okay, so once the satellites are launched into orbit, they'll provide a wealth of data, right? So here is some visual data that I downloaded from NASA, and they have some great public data on provided by satellites. So we have everything from hydrological data on snow, and data on fires. And we have both qualitative and quantitative data on fires. So this is an example of some of the data from these satellites that we get from about fires. And this is not from the past 2 weeks. This is actually from a couple months ago. But here in this GIF, you can see these red dots around the Earth. And these red dots or hotspots are where we're getting wildfires. So this is what we call fire pixels. So the satellite is getting information of where we're getting fires around the Earth. In addition to this type of fire location data, we can also get from satellites fire data relevant to different types of emission. So I like this video that they had on their website, the NASA website, which is some information of how different emissions might move, or aerosols, sorry, might move from one part of the Earth to the other, right? So you have this dust moving from Africa through the Atlantic, and it's really nice to be able to visualize how that how different aerosols might move. And we can use some of this information when we're studying fires, right, to understand how the different pollutants are moving from a fire to other regions nearby. So now you have an idea, a rough idea of what type of data we might be able to get from satellites, right? And there's a wealth of data out there, and a lot of it is public. So you can go on and explore it from various different types of sources, right? And scientists and engineers use different tools, myself including, such as data mining, coding, and visualization, in order to analyze this data to extract quantitative information from it, right? So we want to be able to get scientific data from the information that we're getting from satellites, and for that there's various different scientific and engineering fields that are using this data in different ways. And with that, last but not least, with our discussion of satellites and the different types of fire behavior drivers, I wanted to conclude with a neat tool that you might want to try at home, which is Gridfire. And this is a web-based video game that I developed along with my colleagues when I was a graduate student at UC Riverside. And this is a game that teaches you how these drivers that I spoke about today will drive fire behavior. So you will be playing with these different parameters, and you will be seeing how a fire grows. The game also has a glossary of terms and a guided lesson in case you want to have a lesson accompanying your interaction with the game, and I highly recommend that you try it out. With that, I'll thank you all for your time. If you have any questions, feel free to email me at jacobian3@ucmerced.edu. Thank you.
Thank you, Dr. Cobian Iniguez, for sharing your time and research with us. Up next, we have Lenya Quinn-Davidson talking about prescribed fire burns. Lenya is a core staff person for the Fire Adapted Communities Learning Network, where she acts as a member liaison, develops quick guides and other materials, and supports the community of practice for using fire and the watershed management community of practice. Lenya also works with the Fire Learning Network to coordinate their prescribed fire training exchange. And she's the director of the Northern California Prescribed Fire Council. In this talk, she'll share more about the importance of prescribed fires, how to incorporate diverse, community-centered perspectives into fire management, and programs that offer broader training in fire management. We hope you enjoy this conversation.
Well, thanks so much for that introduction and for the invitation to be here and give a presentation as part of this series. I am going to start off this presentation with a recent video that was put together by the Washington Post. And I think it provides some really helpful context for the conversation we're about to have about fire in California.
Massive wildfires are burning across Northern California.
Tonight in Oregon, devastation and desperation.
Wildfires continue to wreak havoc on the West Coast.
This is America Fast Forward.
Since August, over 4.5 million acres have burned across California, Oregon, and Washington combined, with thousands of people displaced and dozens reported dead or missing.
We've passed a tipping point. What's happening right now is complete triage where we're just putting resources where the highest priorities are and really can't keep up with the scale of fire that's happening.
Human-caused global warming has and will continue to change climate, resulting in longer, hotter, drier fire seasons. These megafires, this is the future. It's now.
The West has long been shaped by fire. But global warming, decades of fire suppression, and poor fuels management has resulted in increasingly more destructive fire seasons.
When we say megafires are because of climate change, we aren't talking about the ignition source. And we also aren't talking about the availability of fuels. What we are talking about is the condition of those fuels.
Since 2013, Stavros has been studying fire behavior and how climate change will impact the likelihood of megafires out west.
We basically predicted that across the entire western United States, the likelihood of megafires is going to increase by 2 to 3 times, or 3 to 400%. And we expected that to happen under the worst case climate scenario. And we expected that by 2030. And it's 2020, and it's already happening.
States like California have a complicated history with fire.
There used to be very frequent wildfires in California, but they would be ground fires. So non-destructive fires, fires that burn the underbrush, the understory of the forests, but that would rarely reach the crowns of the mature trees, and so would rarely have the destructive effects that we see here, or rarely grow really big in size as well.
Climate scientist and tree expert Valerie Trouet studies tree rings in order to understand our climate history. From those rings, she can see scars left behind from fires, an indelible mark from the past.
What's interesting is that we see these very frequent fire scars in the past, but we barely see any scars at all in the 20th century. So that fire regime of frequent ground fires disappears with the establishment of the Forest Service in the early 20th century. So when the Forest Service was established, Its mandate was to protect forests, including western forests, and part of that protection was protection against wildfires. And so we started systematically putting out those naturally occurring ground fires. And we were very good at it, very, very efficient, very effective.
This led to an explosion of growth, a dangerous fuel imbalance that is being exacerbated by a hotter and drier climate.
Instead of 10 years worth of flammable material, we now have 100 years worth of flammable material. And now when a fire happens, it immediately reaches its crowns and it becomes the kind of destructive wildfires that we see throughout the American West.
Fire used to be a tool and a process that was very beneficial to human communities, you know, whether it was Native Americans or ranchers and other groups. And when we broke that relationship and took fire away from people, there were huge implications for the landscape.
For Quinn Davidson, one of the solutions is to give communities the tools to prescribe their own fire burns, to embrace fire, not suppress it.
When we think about that fire-adapted future in California, wildfire is going to be a big part of it. We want it to be a big part of it. Wildfire has so much potential to do good work, and we need to be thinking about what we can do, you know, as community members, as residents, to increase our own resiliency. And we should really be focused on landscape resiliency, on community resiliency, and on bringing fire back in a way that makes sense for all of us who live here.
Fire doesn't just heat your food, it doesn't just keep you warm, it also manages and maintains our environment and helps everything rebalance itself so the ecosystem stays healthy. We take that very seriously. It's something that we teach our children because we have an oral history and not a written history.
For millennia, indigenous tribes in this region have practiced traditional controlled forest burning techniques as a way to tend to the land.
For the natives, we know what we need to do. We know that we need to work together to make this better. We do training exchanges, which basically teaches the community, and we have people coming from all over the world. It's not just our community. So they're taking our stories, our lessons back to their countries, back to their people, and telling them that, you know, there's a way to do this. There's a way to restore the land and a way to care for yourself that's not detrimental to the world.
Apocalypse comes from the Greek apo, which means un, and kalapatin, which means cover. So when you put it together, it means uncover. And apocalypse is an uncovering of faulty assumptions that you've made about the system that you had before. Between COVID, social justice being reignited, and with these massive fire seasons, it's quite literally an apocalyptic year. It is a time for us to uncover what wasn't working and reveal what we want the system to be. And it's a chance to rebuild that system.
That video gives great context for the presentation that I am going to present right now. And I'm here to talk about prescribed fire in California and how we can rebuild California's fire culture, engaging with communities and bringing fire back in a meaningful and appropriate way for Californians. So one thing I think that's really interesting in that video is the conversation about fire regimes and about the complexity that we have around fire in California. This is not just a climate story. It's not just a fuel story. It's not just about where and how humans live in California. It's all of those things. And we're dealing with a confluence of a lot of complicated factors that are contributing to how fire behaves. I really like this figure because it shows fire at different scales of space and time. And you see there that the fire regime, the pattern of fire on the landscape over time, is really dictated by climate, vegetation, and ignitions. And humans play a big part in that. They're a big part of the story. One of my favorite papers in recent years was actually published by Alan Taylor and by Valerie Truitt, who is in that video. And it linked fire regime shifts in the Sierra Nevada of California to human patterns of settlement and of land management. When the authors set out to do this study, they were looking at historical fire regimes in the Sierra Nevada over a 400-year period, and they were trying to link that to climate patterns. They were interested in seeing how climate might have directly affected the fire regimes. And there were some pretty clearly demarcated shifts in the fire regime, in the frequency of fire and the severity of fire. But they couldn't find a linkage to climate. And so they had to kind of go back to the drawing board and start thinking about what else might have been influencing the fire regimes in the Sierra Nevada. And what they found is that they were directly linked to patterns of human settlement and management. And I think that this paper is really critical for us to understand the power that we have as humans, and that we have a role, and that we've always had a role in dictating how fire is going to relate not only to us, but to the climate. So during the periods where humans were most actively engaged as stewards in managing the land and managing fuels, the climate had the least amount of impact on fire patterns. So let's just keep that in mind as we move forward with this presentation, that human action can actually overwhelm climate influence on fire. So a lot of my work as an extension professional and as the director of the Northern California Prescribed Fire Council is focused on bringing fire back as a tool. And prescribed fire is the use of fire under certain conditions to meet predetermined objectives on the landscape. And this could be a wide variety of things. We use prescribed fire to treat fuels and reduce fire hazard, but we also use it for habitat restoration, for invasive species control, for cultural reasons. There is such a long list of reasons why we might bring fire back onto California's landscape and restore it as a process. And I think it's really important to understand the historical context around prescribed fire. You've probably been hearing in the media that California historically was estimated to burn about 4.5 million acres a year. And it's also estimated that up to half of that might have been human ignitions by Native American communities who were burning for food resources and for other reasons. That's incredible to think about. We don't have good data throughout history on the number of acres per year that were burned. But what we do know is by 1955, ranchers in California were burning approximately 200,000 acres a year on their private ranch lands. That's nowhere near what we were seeing, in the more distant past, but it's still a pretty impressive amount of burning that was taking place in the middle of the 20th century. Around 1980, the California Department of Forestry and Fire Protection, CDF, which is now CAL FIRE, they started up a program called the Vegetation Management Program. And that was their private lands prescribed fire program, which really ended up supplanting the work that private landowners and others were doing on their own properties. And in the early days of that program, in the early 80s, that was the height of the program, they were treating about 65,000 acres a year statewide through their vegetation management program. Now we saw that steadily decline over time. And by 2015, that program, they were treating less than 5,000 acres a year statewide. And that was pretty much all the burning that was taking place on private lands in California. There were some examples of some other small groups or, a couple ranchers out there who were still doing some burning, some tribes still doing some burning. But most of the prescribed fire in recent history has been taking place on federal lands, and private landowners and private citizens and community members have largely been left out. So we're seeing a little bit of a reinvestment by CAL FIRE in prescribed fire, but we also know that we need alternative modes and we need to better connect communities with fire and build capacity for the kinds of local stewardship and local management that might help us overwhelm the climate influences that we're seeing now. So one of the things that's happening right now is the rise of prescribed burn associations across California. And prescribed burn associations are basically community cooperatives. They're common in the Great Plains. There are some in other parts of the country. But really, until just the last couple of years, we haven't had anything like this in the Western US. And they are neighbors helping neighbors, volunteer groups, volunteer fire departments, getting together and working together to implement prescribed burns on each other's property. and to do it really with a volunteer base that keeps it cheap and efficient and really grassroots. And also provides an opportunity for education and outreach and writing grants together. These are the ultimate community-based prescribed fire group. And so in 2017, I was really trying to figure out ways to bring prescribed fire back to California's private lands and to start rebuilding that prescribed fire culture that we did have intact for millennia here, but that's largely been, dead in California for decades. So I went to Nebraska with some colleagues and learned about the model that they have there in Nebraska and burned with a couple of prescribed burn associations and was so impressed with what I saw. And my colleague and I came back from that trip and we decided to form a prescribed burn association in Humboldt County where I live. And that was the first of its kind in the Western US. We officially formed in 2018. And the momentum and the excitement around this model, which was so new, so new to California, it's been astounding. It's been amazing to see how many people want to get involved and how many community members want to have a positive interaction with fire and be part of a solution. So the Humboldt County Prescribed Burn Association, we do burns in all different kinds of fuel types. We've got a really diverse ecosystem in Humboldt County. We have oak woodlands, we have coastal prairies, we have forested lands, we have large grasslands, and we're burning in all of that. And in the last couple of years, we've treated about 1,300 acres and done about 24 different burns. And we have approximately 90 community members involved in this group and receiving training and just really contributing a diverse set of skills and assets to the group. And what we've seen over time in these last 2 years is that other areas were hungry for this too. And when Humboldt started up, we immediately started getting a lot of calls and interest from other counties across the state who also wanted to do something similar to this and who were ready to take fire back as a tool and bring it back into their community toolbox instead of just having it be in the hands of the state and federal agencies. So you can see here on this figure that these prescribed burn associations are starting up all over the state. The blue counties here are areas where groups have already formed just in the last 2 years. They have formed all over the state. There are also in the orange groups that are in formation, getting grants, trying to identify partners. And then in the yellow, these are areas that I expect will have a prescribed burn association in the next year or two. So across California, we are seeing this community movement for prescribed fire and people really reclaiming it as part of their local culture and their local identity as land managers and land stewards. And it's really exciting. I think, one of the things that I like to think about is a difference between California and, for example, the southeastern US, where they do a lot of prescribed fire, is that in California, we tend to think of prescribed fire as just a fire management tool, something that fire professionals and fire experts have access to and use, but that normal people don't really have a connection with. In the southeastern US, prescribed fire is a land management tool. And anyone who's a good land manager and a good steward would have fire in their toolbox. So that's what we're trying to work toward with this California Prescribed Burn Association movement. Now, another big piece of the puzzle and something that I work on both here in California and nationally are prescribed fire training exchanges, or TREX. And these prescribed fire training exchanges are something that was spearheaded and innovated by folks with the Nature Conservancy and the Fire Learning Network about a decade ago. And they are typically two-week hands-on prescribed fire training events that invite people from any kind of background, any affiliation, to come burn together and learn about different fuel types and really improve and advance their prescribed fire qualifications. And that might sound like, yeah, it's a cool training, but actually this was very monumental when these first started up, because typically, and before TREX came about and before the rise of the prescribed burn associations, there was really no venue for an average person or a university student or a nonprofit organization or even a tribe to send their folks to get prescribed fire training and build their skills. Those kinds of opportunities were largely limited just to folks who work for fire management agencies like the Forest Service or the National Park Service or CAL FIRE. So this TREX model has opened up so much opportunity for different kinds of people to learn about fire and to formally become part of the fire workforce and to bring prescribed fire back to their communities. And one of the foundational, one of the premises of the TREX model is that we really need all hands on deck for the fire problem. We need everyone involved, and we need all different kinds of people. And our problems are so complex that we really do need to elevate diversity and intellect and talent and perspective in order to solve our fire problems. So we can't just rely on the same people or the same organizations that have always been doing this work. We need to bring new people in, and we need to create opportunities for those folks to contribute in meaningful ways. And TREX is a way to do that, to bring people in and give them training and opportunity. So we host these events all over the country and even internationally. We have partners in Spain and in South America and all over the place who are hosting events in with the same model of bringing diverse people together and building skills, working together, and networking. And each TREX has its own flavor. They are typically hosted by a local organization or local agency partners or tribe, and have their own emphasis or their own flavor to the work that they do. So our partners in the Klamath River area of California, up here near where I live, host TREX every year, the UROC TREX. And that event has a real focus on cultural burning and on indigenous practices and on helping outside people understand what cultural burning looks like and how it can be beneficial to all of us in the overarching fire culture. The TREX has also enabled them to bring fire back as a tool for their tribal members, because there was a long time where they were not allowed to use fire. And some of those skills were lost to some extent. And so TREX has given them the opportunity to work with outside partners and to work with tribal members and really to bring fire back as a cultural practice within their community. Another event that I host every year in different parts of the country is the Women in Fire Training Exchange, or the WTREX. And this is a TREX that is focused on women and other underrepresented groups. And we bring them together to train and learn together all over the place. So we have women coming from all over the world. Last year we had women from 20 different states and 8 different countries, and we include men in this event too. It's important for us to have men and women together learning about all these issues and work on their fire skills. So we've been in the north coast of California, we've burned in Yosemite, we were in Florida in 2019, and this year we were supposed to be in Virginia, but of course things got derailed by COVID. So we're hoping to be back in Virginia next year. But this event's a really powerful one for women in fire to receive a safe learning environment and a chance to meet other women. A lot of women who work in fire are the only person on their 20-person crew or the only woman on their entire district. And there's a real sense of camaraderie that's built at this event. Other events, other TREX events also focus on private lands, on different habitat types. It's just a real wide range of training experiences that are offered here. And this is the kind of thing that anyone in the audience who's listening and might be interested in being involved in a TREX can reach out and learn more, and you can attend. That's the beauty of those opportunities. So in summary, just some final thoughts to wrap up some of the things that I've been talking about. And I think one of the key things that I always want people to understand is that human communities have a central role in creating and maintaining landscape resiliency. And I think we need to get away from thinking that nature is separate from people. nature is human nature, and we as humans have the opportunity to have a really positive role in managing our landscape and making it what we want to be. And fire is one of the most powerful tools we have to do that. And we see that throughout time in California. Most of the areas that we know and love in California have been shaped by fire, and they have been shaped by humans. So let's own that, and let's take full advantage of the responsibility and the role that we have as part of our natural world. And diversity is key. If we think about natural communities and the power of biodiversity with a changing climate, under any kinds of circumstances, the more diverse you are, the more resilient you are. And so in fire, in thinking about prescribed fire and the workforce and the communities, we need everyone at the table, and we need everyone involved, and we need everyone contributing their amazing ideas and their different perspectives. So diversity is key in natural systems and in human systems. And we know that we can moderate the effects of climate, but local capacity and stewardship are essential. So don't let the climate narratives completely overwhelm you to the point where you feel, that you just have to throw in the towel and leave California, because I don't think that's true. I think we have an opportunity to re-engage and to learn from the cool studies like the one I shared earlier, where we know that human communities can have an effect and really moderate some of those effects of climate change. But we have to act, and we have to act in strong and powerful ways if we're going to make a change. And part of that is going to be rebuilding California's fire culture and really learning to live with fire and learning to engage with fire in meaningful ways that are not just scary. So this is my son when he was 3 doing some burn piles, and I really hope that by the time he's my age, he'll be a polished fire practitioner, and he'll be using prescribed fire to manage his landscape and to make California a place where we can all live and be happy. So thank you so much for including me in this speaker series, and please feel free to reach out if you have questions or want to get more involved.